2, 3.
All right, got the
Go.
recording started.
Yep. Yep.
All right,
Go.
so my contact information is up here. So if you have other questions after this that you forget to ask, go ahead and hit me up on Twitter, or I put my email address there. I will be at PASS Summit, and I'm also going to be at Microsoft's Data and AI conference in December. So if you do have a travel budget and a training budget, I highly recommend, and you don't get to go to PASS Summit, hit them up for going to Vegas in December, so I can meet you in person there. All right. Let's start talking about Azure Synapse. First, I wanted to talk a little bit about the architecture and kind of talk about what Azure Synapse is supposed to do. It's basically designed to solve a problem. And that problem was basically, where do you put all the data that you have that doesn't necessarily fit? Or can you get away with not having necessarily a database? And what is this thing about pools? And so that's what I really want to talk about. Azure Synapse architecture basically sits on top of an Azure Data Lake Gen 2. So you can create a data lake as your warehouse, and we'll talk about how to do that, some of the limitations for that, but some of the ways that you can make that work. And with Synapse, all of the compute and storage are separate. So what that means, if you want it to go faster, you can create a new compute engine and use that compute engine with your same data to make things go faster. It does also include a lot of different components. I know that Microsoft likes to refer to this as it's an what is it, YASI, which is not yet another Spark interface. There's more to Azure Synapse than that, because it includes more than just Spark, but it definitely does include Spark as well. It also includes Azure Data Factory components. It's pretty much lift and shift of all the features and functions which exist in ADF. There was one component that was not incorporated into Azure Synapse, and that was added later. So that is now in preview. So that the last thing to be added was the ability to pick up SSIS and migrate that to Azure, and that is now in test. So it's basically now the same code as ADF. So we'll talk about why you would want to incorporate all of that in one space. And then if you were wondering, hey, didn't Microsoft used to have an Azure Data Warehouse? Whatever happened to that? Well, it is now a part of Azure Synapse. It was actually the first part that was released, and it is incorporated as a dedicated SQL pool. And it is really a data warehouse. It's designed for very large data sources. So if you have greater than a terabyte, that is where you want to put your data. And then, of course, it does incorporate Spark, and we'll talk about how to use Spark. I am presently doing quite a bit with Spark right now, but surprise, surprise, I'm running a lot of SQL. The difference is, when I am writing SQL in Spark, I'm not writing Transact SQL. I am writing ANSI SQL. So I get to find out that get date is current _ date. And a couple of other little things that just make me have to go to Stack Overflow to figure out how to do it. It's not Transact. So let me talk more about it. So let's talk initially about this different compute. So there's 4 really different kinds of compute. I'm not including KQuil because it's in preview, but that is yet another pool. So for your pools, these are your compute engines. This is the computer that you're going to be running on. And the dedicated pool is the computer, or the compute, that is dedicated to data warehouses. Now, this does not, if you create a Azure Synapse workspace, you don't automatically get one of these, because they don't know if you have a terabyte of data and how much compute space you want. So that's an optional thing. Now, serverless is not optional. It comes with a Synapse workspace. What the serverless pool allows you to do is allows you to run queries on top of flat files. And that is a really big strength of what you can do within Azure Synapse. While you can do it in Databricks too, because I always get asked, hey, what about Databricks if we're talking about Synapse? It's a lot easier to configure. It incorporates also a Spark pool. Now, again, you have to create Spark pools as well because Microsoft doesn't know if you want one of those or not. And the different Spark pools have to do with what kind of compute you want. Unlike the difference between a Spark pool and a dedicated pool is Spark pools turn themselves off when they're not in use, and a dedicated pool runs until you tell it to turn off. I have heard that there is going to be a future update that is going to make it so it's possible to turn off dedicated pools when they're not in use, but presently that doesn't exist. So if you want not to be charged, you need to turn it off. With Spark, when it's running, you're charged, and then after that, depending on the timer, when you're not using it, it'll stop by default 15 minutes after you're done using it. And then you also have an integrated runtime component. This is also created when you create your Synapse workspace. It is also a Spark pool, but this particular type of Spark pool is used to run your Azure Data Factory, your integration components. While there is one that comes with the Azure workspace, their Synapse workspace, you can also create an additional one should you want additional compute power, if you want to do that. So these are the 4 different pools that you can be managing within Synapse, depending on what kind of workloads that you want to do. So what is a dedicated pool? Well, the dedicated pool is the new version of Azure Data Warehouse. It is created by the user, and you're charged when it's running, but you can always, as Amina put it, you can always turn it off when you don't want to use it. You can also set up PowerShell scripts so that it has specific hours where it is in use. I know that I have a client that is presently using it, and they not only do they have a PowerShell script that turns it off on the weekends, it also scales the dedicated pool size up and down as well. So maybe during the day, you've got a lot of use on it and you have a very hefty pool, and then you might change it over to a lighter pool when you've got a lighter workload. And that is something that you can do as well. It's very easy to change the configuration. If you wanted to go from one pool to another pool, it'll take about 4 minutes because you have to load the other one up. And it is designed for a terabyte or more. If you do not have a terabyte of data, it's not designed for lighter workloads. If you do have a lighter workload, you're probably better off looking at a Azure SQL DB, because you can definitely create data warehouses with it. But if you've got large data, this is what you want to use. It's got a lot of really neat workload built-in capabilities so that you can give different tasks and different people advanced resources so that different things will work better depending on what you want it to do. And you can use it for doing any kind of querying, again, on really, really large data sets. And it will handle that fine because that's what it's designed to do. It uses a massive multi-compute engine so that it is running multiple threads at any given point in time, and it splits out the workload between those, and you can configure it based on what kind of data that you want and what kind of clusters as well. The next kind of pool is the serverless pool. So you can use this to query your data lake, and this uses T-SQL. I wanted to make sure that you remember that. So if you want to write a query in it, not only will it generate code for you, but you can write your own using T-SQL. So you don't have to remember how that it's limit 10 if you're using Transact versus just top 10 if you are doing T-SQL. And you can use this over any item within your data lake, and I'll show you how to do that. Depending on what you are querying has to do with how long it's going to take to return your queries. Because it allows you to query a flat file, it looks like a database, but it's really not. It is a layer on top of your flat files. So that means that you can't index. It doesn't have all of the full features of SQL Server, but it's also, priced a lot different as well. So we'll take a look at how to use that. With serverless pool, there isn't presently a way of making this bigger. So if you wanted your stuff to go really fast by putting in another pool, you can't. This is what you get for serverless pool. It is the one kind of pool that you're not able to configure. The other pool is for Spark. Now, Spark is used to write code. You may find that you want to write it for ETL or extract, transfer, load, or any more. It's extract, load, and transfer. Or you can use it for machine learning. Spark was originally created to solve a machine learning problem trying to find the best algorithm for Netflix. It uses Python, .NET, or Scala. So if you want to write .NET, you can. You don't have to write Python or Scala with it. It also incorporates SQL as part of the tool set. It's not necessarily a language, it's just what comes with it, which is why I didn't spell it out. It's based on on a notebook, so you use it with notebooks. The notebooks that Microsoft has incorporated into Azure Synapse are called Interact notebooks. It's just a flavor, just like another flavor that you might be familiar with is a Jupyter notebook. Interact is very familiar, very similar to a Jupyter notebook, but they just have a WYSIWYG editor when it comes to markup, so markup is easier to write, which I appreciate. It is not the same as Databricks. I know that Databricks is also used to write Spark, but the Spark that Microsoft is using is open source. So Microsoft is using open source Spark. So if you wanted to, you could write Spark on your desktop and then migrate it to the cloud, and it would work as, similar fashion. You have to just change your data connections. But Databricks is not the same because Databricks uses a proprietary version. So Microsoft is all in on the open source, and Databricks is using a version of Spark that they created. What that means is you can't exactly copy your code from one to the other. It's close, but it's not 100% lift and shift from Databricks to Synapse because they're using proprietary Spark. So let's show you how to set that up. I'm going to show you what I call the cooking version of a Synapse environment, show you how to create one. I highly recommend that you go create one because creating one's not going to charge you. Using it, yes, but just creating it, no, you can do that. And then according to what you do, of all the things you can do in Azure, a lot of Synapse is very inexpensive because for your serverless pool queries, you're only charged $5 per terabyte. You can query a lot before you hit that terabyte limit. So this is the done version. Let me show you how to create a new version. So I'm going to go ahead and select Azure Synapse Analytics, and I'm just going to create a new one. Now, another thing that you can do, and I'm doing this with my clients, so I anticipate this is something that you might want to do as well, is incorporating your Synapse code. Perhaps you write a database, or you write a virtual database using serverless, or you're manipulating data in the data lake that you intend to incorporate into Power BI. If you're doing all of that, you're going to want to make sure that you are in the same place that your Power BI is located. So I'll just show you how to do that. So when you're creating Synapse and you want to incorporate it into Power BI so that you don't incur charges for moving data back and forth, you want to make sure that you are creating your Synapse workspace in the same location as your Power BI instance. So if you go to About Power BI, you will see that I am in Central Iowa because I had this great idea when I was bored because I was consulting in Iowa that I was going to create my my Azure instance there. And so now I'm stuck with it in Iowa. So, but this is where I would want to create my Synapse instance so that I wouldn't incur any data charges going back and forth between Power BI. So just keep that in mind. Resource group, you can go ahead and create a new one or use an existing. I'm just going to call this new. And I can spell. And this is just my resource group. And then I don't need a managed resource group because I'm not going to necessarily use one. If you want to do that, that's an optional thing. And then the workspace's name, then I would have to give it a real name. So basically like test. And region, again, because my, fine. My Power BI is in Central US. I want to make sure that my Synapse is in Central US as well. Now, the next thing that you'll see here is my Azure Data Lake storage. So I mentioned the fact that Synapse is built really on top of an Azure Data Lake. So you're going to need to either create one or use an existing one. You don't have to create a new one. If all, again, going on trying to be accommodating to reducing Azure spend, creating a data lake is one of the more inexpensive things you can do. So why not create another one? It's not going to hurt anything. When you do create a new one, it's going to go wherever you said that you're going to have to put it. So again, it's going to be in this resource group in this region. And I'm just going to create a new plus. Create new, right? Okay. Now it's asking you for the file system name. So for the file system name, all this really is with an Azure Data Lake, you are basically creating a logical file structure on top of a blob storage. So basically, think of this as kind of like a giant, a giant disk drive in the sky. So you just need a name for your top level folder. And I'm generally pretty uncreative with what I call my top level folder. So I generally call it root. It doesn't really matter what you call this as long as you remember it. Using something generic means that you can use it for whatever you want, which is another reason I like calling it root, because I'm going to put different things in it. So I have to give it a name. So root's good. And then, of course, I want to make sure that I have appropriate levels of security to write to it. Otherwise, that would be too helpful. So I'm going to make sure that I leave this checked. And it's telling you, hey, you're going to get the workspace identity. And then when I say review and create, what's going to happen is in about 5 minutes, it doesn't really take that long, I'm going to get this. So again, cooking school, ta-da, I'm done. So what I have here is I've got my Synapse workspace, and you'll notice here that I have this thing called a serverless endpoint. And what is this? This is the name of, so my primary ADLS account is called Synapse Data Lake. And if I have this serverless endpoint, I can, and I will, because I'll show you how, connect to SQL Server Management Studio using that endpoint. And this is where I'm going to have my databases. My virtual databases that I'm going to create are going to be on this server, because that's how it shows up. So within this environment, it shows me that I have a serverless pool that's built in and created. So let's take a look at how you're going to be working with Synapse. And that's just opening up the studio. So within Synapse Studio, that's interesting. Oh, because I picked the wrong thing. Hello. Too many accounts. So this is the Synapse workspace. You can see here that this is the front, this is the home area. So I blow this up, you can see the actual little names. This is the stuff that I've done recently. If you want to start playing around with this, it's pretty easy to do that starting with a knowledge center, because there is working code that comes from shared data sources. So you can click on this and just get started with real data. From the data pane, this is where I can look at the stuff that I have in my environment. So if we click on linked, this is where I have my data lake storage located. Now I've of course added some other things too. But this is, I only can have one primary because that's how the world works. Only one thing is primary, but I can add multiple different Azure Data Lake storage to my account should I wish to do so. So in my primary, you'll notice that my root is my top level directory because I am that boring and that's generally what I name it. I also have an archive area, and then I have a data lakehouse. And I've also got a bunch of integration data sets because I have created integration pipelines and I have data sets associated with those. I also have a Cosmos DB connected to this. And while it's in preview, you can also link a Azure SQL database to your elements as well. So I could incorporate data from my Azure SQL database into this environment as well. So what can I do? I'm like, okay, so I've got this linked area and I've got a Azure data lake. So that's mildly interesting. What is this stuff anyway? Well, let's take a look at it. So within my raw area, I've got some data. Well, let's take a look at my data. Here's some JSON data, and here I've got some CSV data. I've got some Salesforce data. And if we look at this, we'll notice that this is in a weird format called Parquet. And Parquet is a format. The reason it has a dumb name is it's part of the Hadoop collective, and it is a compressed format. It's actually quite similar to a column store index within SQL Server. So it does column store indexing, which means that if you store something in this format versus, say, a CSV file, then it is going to take less space. It's also a little bit faster to query. So because again, it's compressed. So what is in here? What I want to take a look at this. So I'm going to go ahead and say select top 100 rows. It went ahead and generated some code for me. So it's using the open row set command. It recognizes this as Parquet format, and I can take a look at my data. And again, I just right clicked on the file to get this. Now, is this the speediest thing on the planet? No, but I am looking at a flat file. And notice it translated this from the Parquet format, which is something you can't read, into a table. So I can take a look at all of these different elements and seeing what I've got within my files. So you're like, oh, that's it. That's mildly interesting. What about CSV files? So what if I wanted to look at them? Well, here I've got some hotel reviews. So if I'm going to do the same thing again, I'm right click to get this menu. And I'm going to say that I want to do select top 100 rows. And it knows that this is CSV format. So if I just run this, now notice it didn't know that I had a header row there because it doesn't by default know that about CSV, but that's okay. I can basically tell it that it has CSV. In addition to having that, of course, it has IntelliSense. So I can just type and have it come with commands for me. And I'm going to say, yeah, that's true. And so now I know that I can say that I do have header rows. And now when I run it, it's going to give me, oh, because I forgot to put a comma there, that it's going to give me my headers. So this is basically looking at a whole bunch of hotel reviews that I happen to have, and all of the data that I have within there. Now, you'll notice that I keep on closing this thing. I can save anything that I want to. You'll notice here also that I have integrated my Synapse environment with Azure DevOps. That's what this icon is. I've got a dev branch and I have a main branch. I can also choose to incorporate it into GitHub if I want. So all of my stuff, when I connect, when I say publish, it will publish to my Azure DevOps GitHub repository. And it tells me which one it's going to do because those have the dots next to it. So when I say publish, it's going to want to put these different elements within my repo. So I'm probably going to want to go in here and rename this if I did want to do that so that I have real names. So let's take a look at how this what happens to SQL. Should I actually say that I want to store it? I don't want to store this. If we look in this develop area, we'll see that I do have a lot of SQL scripts that I do have saved off. One of them is just basically looking at a copy command. So basically I'm creating a table using a column store index. So I'm using this for a dedicated SQL pool. Notice here it tells me where it thinks it wants to connect. I've also created an external file in a logical data warehouse, and I've saved that off. And notice here it's getting it from a CSV file. So these are where I can save off my scripts. Now I can be fancy, and like I've done with my other notebooks, I can create folders and put elements into folders so that it's a lot less messy than what I have up here. So this is where I would save off SQL, and this is where in my other notebooks, this is where I'm creating different kinds of Spark loads. So this is some Spark code that I have to have. And notice here, when I've selected Spark versus when I have selected this, notice here it says it's connecting to built-in. Built-in is my serverless pool. And here it wants to connect to my medium Synapse pool. This is a Spark pool. It says Spark Python. That's kind of a giveaway. So I can so I have different kinds of things saved in different kinds of notebooks. So, and this of course is Markdown. So I could edit this and if I wanted to, basically, that I want to capitalize that, can delete it. And then I've got my different code elements. So we'll talk a little bit more about Spark here in a little bit, but this is the develop area where I've got things saved off. And in integrate, this is where I have some SQL pipelines. So here I am doing something where I am getting a whole bunch of data from Salesforce and then loading it. And then I am using notebooks to write it to my stage area and then writing it to my curated area. So this might be something that you might want to do rather than everything, than doing it with everything being a data flow within your integration. So you can also incorporate notebooks as well. I could also incorporate any SQL that I wanted to in here as well. Next thing I have here on the left is monitoring, so I can take a look at what I've been doing. I've got SQL requests, I've got KQL requests, I've got Spark applications, and here is where I can also look at the status of my pools. So I can see that the built-in is started, my small pool and my warehouse pool, they are paused. So for Apache Spark, I do have a couple of pools here that I could take a look at. If I just click on this, because this is just monitoring, all this is going to tell me is how I've got it configured. And these are the new Data Explorer pools, and these are designed for KQL. So if I have pipeline runs, they would show up in here. I haven't done it here in a while. On my integration runtime, which is running, so I could create a pipeline and run it now. And my link connections, if I've run anything to that. So in the manage area, you can also have the ability to turn things on. So I could turn on my dedicated pool, or I can take a look at my Spark pools. So, looking at the configuration, role assignments, different elements within it. And then looking at my linked services, I do have a number of different linked services incorporated here, connection to Salesforce, connection to Osmos DB, Key Vault, so that I can incorporate these different elements within my Synapse environment. And I've got my source control for Git configuration in there as well. So that's what it contains. So that's kind of a high level overview. So I wanted to talk about what kinds of things that you can do within Synapse. So one of the things, of course, you could do is a modern data warehouse. And the reason that this is kind of a modern data warehouse is probably how you're going to orchestrate it. So let's say, for example, like a recent client that I had, they had data in a number of different data sources. And traditionally, you might create up an ODS and then take things over from the ODS. Well, in a Synapse environment, what you're probably going to do is put all of your data into the data lake. And then from there, combine it together. And you can do that again through data flows if you want to use that in pipelines, or how I do it, which is basically using Spark SQL instead of using data flow pipelines to do it, because my clients like the fact that they can read the code easier and they're terrible at ADF. and it's also runs rather quickly as well. So I still want to, get that to that one source of truth. I am going to be gathering data from multiple sources. I want to transform data into a dimensional model, and I want to develop it in the cloud. Now, what's different is where I'm going to end up, what I'm going to end up using as a tool for this. Because I have different kinds of user demand, I need to keep some of that data in its original form. For example, let's say that I am managing a fleet of vehicles, and so I get um, notifications when the vehicle is in operation every 10 seconds. Well, that's a lot of data, and I probably don't want to keep a ton of that in my data warehouse. I might want to just put in some aggregates. But let's say that we want to analyze all that data. I'm going to definitely want it. So we need to keep data in its raw form, as well as do the ETL on it. Well, that's what your data lake is good for. So I could keep that raw GPS data, and I could probably keep that, for years. It's not going to cost me much because, again, data storage is not very expensive. And then my anybody who is doing a machine learning analysis on that can have access to that data. But I also want to do reporting. So how am I going to handle my reporting? Well, what I have found to be a really good use case is to create data marts that can be used within Power BI. And of course, that depends upon the size of the data that people have. I may want to directly connect, do a direct connection to my dedicated pool within Azure Synapse, but I might also just want to create a virtual database where I have joined up all the data for my users so that we can just use that as a starting place for where we're connecting into Power BI. So I'm creating a virtual database, and I'll show you how I'm doing that within Spark SQL. And that allows me to provide a warehouse that's a virtual data warehouse. It's a good solution if you don't have if you have less than a terabyte of data. And if I have something like maybe I have a half a terabyte of data, maybe I want to take that data that I have and move it into, say, an Azure SQL DB, because that would be a more appropriate size for, that lesser size of data. And it's easy to do that once I've got it all cleaned up. And I can look at, archiving and formats, having different formats so that I can store the data in a way that it's going to be economical and build things up. So what do I have for options? So I can use Azure Synapse Analytics. I can incorporate all these different elements from within Azure Synapse, but Cosmos DB and Cakewell, those are really um, data storage elements because they use other things. So these are really the ones that you're looking at that you can incorporate within Azure Synapse Analytics. So one thing that you can also do is you can incorporate serverless with on top of your Azure Data Lake. So you can create a virtual database using Parquet files because they do tend to perform a little bit better if you're running queries in a virtual database. And it's completely accessible in SQL Server Management Studio. As a matter of fact, there's something that SQL Server Management Studio does better than Azure Synapse environment. So there's some things I do within the Management Studio because it's easier. So you can do this, and I'll show you how to do this in the next demo. So when you're deciding what you're going to do, you've got some architecture decisions that you need to make. So, I can, use a virtual database, have it using Parquet files that will perform really well, and I can access it through SQL Server Management Studio. But if I have got a lot of data, that's probably not going to be a very good solution. So if I don't have a lot of data, it could be a very good solution because then I can, just incorporate Power BI and people can use that as the source engine for Power BI. So that is one option that I can do. Now, what I generally propose anymore to clients is I say, look, let's try because I don't generally have gigundo clients that I'm like, oh yes, for sure, you need a dedicated SQL pool because you have over a terabyte of data. I tend to have smaller clients. So what I tell them is, look, we'll create up a virtual database because it's not terribly difficult to do because we still want to do that ETL process to make sure that your data is properly organized. Yes, I know you can do that kind of thing within Power BI, but some of it, when it gets kind of complicated, uh, I would rather do it in a different tool because that way I can use it in multiple Power BI models should I wish to do that, rather than having to reincorporate that or perhaps put it in the Power BI service. Although you can do that, I tend not to. I think that the solution, I like the ETL tools better that you can use in a more SQL-based format, shall we say. Um, but you could. I'm saying, it just depends on how you want to do it. Um, but if I come up with this external database, so I'm like, well, that's nice, but we still want a SQL database, fine, because I can just take the organized data lake that I have, my curated area that I'm using to create my virtual database, and we can put that into an Azure SQL database should they want to do that. And we didn't do any extra work per se because creating a virtual database is so easy. And I'll show you why it's so easy. It's because you have to write very little code. Shh, don't tell your clients this. They'll think it's really hard. All right, so you got to think about this. How much active data do you need? How much ad hoc query demands are there? And then think about the skill base of your users. What are they going to be doing with it? If you could create a data lakehouse with Spark, and if you have an environment right now where people are like, no, we're using Databricks, fine. You can incorporate Databricks as well. And you can also choose to incorporate a file structure called Delta Lake. And that Delta Lake file structure makes your that makes your files that you have on your data lake perform more like a database because you can do this thing that's called time travel, which sounds like, wow, like super Doctor Who cool. But actually, all it is allowing you to snapshot your data so you can look at a previous snapshot, see what it looked like before, which is useful, but it's not real time travel, unfortunately. And you can use it to develop Spark pipelines if you wish to move and process all of your data. And I'll show you about that. So if I want to create a serverless, a table in a serverless pool, I'm going to create an external table. Now, I was talking to some people earlier about doing this. I'm like, well, you can just create a view. And yeah, I know I can create views without creating tables, but I've been doing SQL too long. That just seems backwards to me. I would prefer to have a table and then have a view be a subset of that rather than just create views. Although I do know you can do that. I don't like doing it. So here, what you can see that I'm doing is I've created I made up a data warehouse. So I'll show you how to do that. And then I'm just creating this external table. I'm saying what I want it to be like, and I'm saying, here's the data, go put that in there. And oh, by the way, notice I got a star here. So if I had, I don't know, I had population for like 5 years, and that was the folder name, it would pull everything out. So I wouldn't have to know everything within it if it had different names. I can choose to alias my data so I can grab more files and put them in my one table. So, you can basically do everything you want within Synapse. All the components are included, so you don't have to use any other tool. You can use Delta Lakes, dedicated pools, whatever size you're looking for, you can accommodate it. So let me take a look, show you how to do some of the stuff that I just talked about. So if we look at how to create a data warehouse, I told you that, it's not any big deal because it isn't. And this code is fully available for copying all over the internet. It's really easy to find. Matter of fact, I think there's even a knowledge base that has this code, so you don't have to do it. You do need to go look up your shared access signature for your primary data lake, but that's what this is. That's my giant secret there. So here I'm creating a new database. So once I run this, I have to change the database to this one before I can run the rest of these steps. So I'm going to create a master key, then create a scope credential, and then point it to an external data source. So I've already done that. And what do you get when you do that? So if we go over here to database, now this is the link sections. This is just my link storage area. But here under workspace is where my databases live, and databases with air quotes. So here I've got several different databases, and here I have one called EMR. And EMR here has a number of different files, tables that I created within my database. So, I did this create child that said EMR, and then now I've got a database. So now I've got a database. Okay, so how do I add stuff to it? And that sounds really hard. Not really. So I'll show you how to create external tables and the process you need to do that. And this is going to involve something that I'm sure you're familiar with, and that is right-clicking. So what I'm going to do is right-click on it and then say that I want to create an external table. And what it is going to say is like, well, okay, I'm going to take a look at your data, previewing it, and saying, hey, this is CSV data. Yep. The first row, do you have column names in there? I'm like, yeah, I have column names. Do I have any string delimiters? No. What's the maximum string length? Well, I just guess on this, and if it's bigger, I fix it. And I'm going to want it, it's going to, I could preview the data here to take a look at, what is in it. So I'm like, well, I can even make this smaller. Maybe I don't need 100. Now this comment's really long. I'm sure I'm going to want to make this one probably longer. So I'm going to go ahead and say, okay, or continue rather. And it's going to say, all right, where do you want to put this? Well, I want to use my serverless pool, and I'm just going to put this in my EMR database. I could put it wherever I wanted to. And what do I want to call this? I don't know. And then it can do it automatically, but I guarantee it's going to blow up because the comments is not as bigger than 100 characters. So I'm just going to say use a SQL script, and then I'm going to have it open the script. And here you'll see that it generated code for me. So it's taking from that CSV file. And like I said, I'm pretty sure that I need to make this bigger. So I'm going to make this 2000, make sure that it works. Of course, I can change, any of these items should I wish to do so. And this is going to use the EMR database. And the one thing that it doesn't do, which kind of annoys me, but I did tell it that I wanted to put it in the DBO schema, and it doesn't ever remember that when I'm creating my tables, but it does remember that when I tell it this is my test. So what this is doing is this is connecting to the root of my data lake. And then, and so it's doing at the root, which is that top level, that's what it's called, of my Synapse 11 data lake. And then from my root, it's going to go to raw, and then it's right inside Fabric. This is the physical location for it. So starting at the root. So my location is going to be path for my root, and that's what this root at is going to tell me. So I'm going to say this is so what I'm doing up here is I'm setting some variables. So I'm basically saying that this is my external file format. It's called Synapse Limited Text, and my data source name is called root of Synapse data lake _DFS _core Windows.net, and go ahead and add the table. So, okay. Now I could actually be clever on this, and I could modify this if I wanted to do that, but I'm not going to. It's fine. And it says it couldn't find, because I have it highlighted. I need to make sure that I don't have anything highlighted. Because it's not. All right, that's unusual. Let me take a look at it and see if it just lied to me. It did. It lied to me. It says it's not accessible, but it's there anyway. So I'm going to go ahead and say select 100 rows off of it. Notice it did to create the table. And obviously it did it with that comment being larger. So I can go ahead and say select. I don't know why it's saying it doesn't exist. But I did create my table. So let's take a look at it. Maybe I can take a look at it within SQL Server. So I'm a Management Studio. So I'm going to go here into Management Studio. And I'm going to go ahead and connect. And I'm going to pretend this is a database because it just acts just like one. And the way that I'm going to connect with this is universal with MFA. How about clustering and partitioning on external tables? Again, external tables are flat files. So I don't really have the ability to, I can partition as in I can put files into different folders, but I'm not really doing clustering on files. If I choose to incorporate Delta Lake, then I can do some kind of clustering with it. But this is not a real database. This is just a layer on top of a bunch of tables. So I am somewhat limited. Good question, though. So I'm going to connect to my database. And it's going to say, hey, you need to log in. And now you see that I have my database here. And I have tables. And underneath tables, I have external tables. And it should let me do this. Why it's not saying it doesn't exist. Great. I guess I did not sacrifice enough to the demo gods because it's not liking my connection at the moment for whatever reason. I will say that I'm doing the same thing to another pool, which I did something that's relatively similar. This is also a flat file. If this one will work for me. I have no idea why I can't just query. I should just be able to. So this is just basically looking at top 1000 of a file that I happen to have in this a different environment, and I'm told it to be a table. So very baffling why I can't query it. But so here, within Management Studio, I can write whatever T-SQL that I want to on top of my files. So again, these are just flat files. So I am, limited into what I can do because they are flat files. So I can't, index them or there are some things that I cannot do that I could do in a database that would make it go faster. Can't do any real indexing to speak of within my SQL environment because it's on a flat file. So how I can incorporate data that I have into different formats and build that is, of course, I can create a pipeline like the one I showed you, but I can also do things like write SQL using Spark. You're like, that sounds hard. Not really, because what I'm going to do is I'm going to connect to my data lake. So, and then I'm going to say what my top level container is, and mine's root, and then give it the path. And then I've got two paths here. So I'm going to use these two paths to load up different files. So here what I've done is these percent sign S's, they are aliasing these items. So this one is aliasing the container name. So it is going to be at, so it's going to be root at, and then it's going to be the Synapse Data Lake, which is the account name, which is the second percent S. And then it's going to use the next percent S, which is a relative path. And then the one following that, which is the file name. So what this is going to do is this is going to read it into a data frame within Spark. And once I have it within a data frame, then what I can do is, I should have done this earlier because it took me 4 minutes for this to load, is when I've got it loaded, I can create this command saying, here's this data frame where you load all the data. Create a temp view. Okay, and once I create that temp view, then I can start writing SQL on it by using this magic command. So when I do this, I can use SQL to manipulate my data, should I wish to do so. Now, within Spark, the SQL that I write here is ANSI. So it's using the ANSI version, which means that you do things like limit equals 10. It's not get date, left paren, right paren. It's current underscore date. because those are ANSI commands. So you may find a couple of areas that you had to rewrite it a little bit. Date add is date underscore add, I believe. And there's some just different things that you're going to have to do to write this kind of SQL, but it's pretty minor. And then when I can manipulate, so here, like for example, it came in as ID. Don't want it to say that. I want to change the format from underscore to like birthday, birth month, and I'm listing the different elements out because I don't want to include everything. And then I can write that to a file so that I've transformed my data to how I want it. And of course, I can choose to join from other files and join them together to create a unique file structure. So I'm doing all of my data transformation, my ETL, as it were, within Spark using SQL. So I could do that, or I could create data flow pipelines. But you have options. So, here what I'm doing is I'm just writing my notebooks, having it run my notebooks. But you can do a full-on data flow if you choose to do that to get your data into the environment that you want it to be. So with that, talk about integration runtime. So if you want to do integration runtimes, it's really an ADF code copy. It is the same code. It uses a Spark integrated pool. You have the monitoring that's within Synapse. So you can take a look at what's running. It does have SSIS integration and preview, and you can easily, if you choose to, incorporate notebooks. You could also incorporate Databricks should you choose to do that. Anything you can do in ADF, you can do within integration within Azure Synapse. One thing to do, remember though, if a lot of times with Synapse, you're probably going to be moving data through these areas. How do you place the flat files in the root of your data lake? Okay, so to do that, it depends on how big and my files and where do they come from. So let's say, for example, I'm going to show you 2 examples of that. So within here, I have data that I have within Salesforce. So I am getting data from my my Salesforce object, and I'm writing that to a data lake. So what I'm going to do from this is I'm going to use a linked service and then connect to data within that. That is, of course, only one possible way that I might have it do it. If the file is small, I can choose to use something like Azure Data Explorer, but I wouldn't do that if it was something that I was going to be doing all the time. I can also create, what I tend to do is I tend to get data using integration. Like, for example, I could also choose to get data, say, from a SharePoint link, a SharePoint place. I could get data from a database. Just depends on where the data lives. And then I would, just generally probably build something within Integrate to get it from wherever it happens to be. Be it a SQL database, on-prem database. If I'm doing on-prem, I can use create an integration on-prem link service so that I can gather the data from there. So it just depends on where your data comes from as to how you would do that. Does that answer your question, Dylan? And technically, good point though, I'm never going to really put it into my root area because I want it into different folders so that I can find it again. I realize that the one that I'm using for testing is a total mess, but when I do this for real, I'm much more picky about where the data needs to be. And generally speaking, for my raw data, I will have a folder underneath it that lists the source. So, or something about the source. So I might say I have a Salesforce folder. I might have like an application name folder. Beneath those, I might have year folders, depending on what kind of data that I have. And again, it depends on where the data is coming from. I could get data from Amazon Redshift. the data could come from anywhere. And I'm going to create probably something with, if it's coming from Redshift, for sure, I'm going to use the integration components of Synapse to get the data because it's easier. I could also choose to write JDBC in Spark, but I'm not up for that much effort. I don't find that rewarding. So what I'm going to do though is I'm going to get the data in its raw form. So, and then I'm going to dump it here. So how am I going to make this happen? How am I going to get data to these different areas? So my raw data is going to be from the source. Structured data might be some combination of different raw files. Reference, like for example, a reference might be if you have different location information that you just want to upload because the locations don't change and they don't have that in their database anywhere. Like the zip codes for where their physical locations are, you might have that in a reference. Country codes are another thing I tend to put in here because there tends to be some discrepancies for different country codes, and I want to make sure that they are all the same. And then I'm going to want to move these out. So I'm going to probably use an integration pipeline for this. And for my raw data, I'm going to use that integration pipeline using my source connection to link to wherever the data happens to be and build it out from there. Once I've got it in this raw area, then I'm going to probably write some Spark to normalize it, to clean it up, then move it to stage. For my reference, it depends on where the data happens to be coming from. Within, if it's small, just dump it over there. I might do integration up for that because I'm going to get it from like a website, and it's just easier to dump it there. And then I'm going to use Spark SQL to create a curated area. And here's, I'm going to actually have a full-on dimensional model where I've got facts and dimensions. And then periodically I'm going to archive my data into a cheaper storage location, something that doesn't need to be in the standard stuff, but we don't want to get rid of it. So I can do that to, get my data into an area where it's going to, where I'm going to have data that I want to keep, but maybe I want to put it into cold storage. So there's a couple of different design patterns that you can use with this. I could use Azure Synapse to SQLDB. I could use a data lakehouse and move that to an Azure DB. I could use Databricks Spark to an Azure SQL DB. They've got a number of different things that I could possibly use with Synapse. So I'm not just like, I'm using a data warehouse or I'm using serverless. You can take your data and put your data in a number of different places and use a number of different tools and use them in combination in whatever way makes sense to you. So in summary, we took a look at pools, talked about different ways that you can use Synapse, how the different components worked, talking about how you can do data transformation, both with integration and with Spark, and then talked about different ways you can do data warehousing. So with that, any questions? Very quiet all of a sudden.
Hi, Ginger. It's oh, go ahead.
Oh, please go ahead. I'll ask later.
Okay. Could you tell us a little bit about the different pools? Why would we want to use dedicated instead of the default pool? Is that just for the power of the compute?
So a dedicated SQL pool is where you would build a data warehouse. So a dedicated pool is a database.
Okay.
And so that dedicated, if you want a data warehouse, that's where it goes. So you would create your files there, you would migrate your data to there, et cetera, et cetera. But again, if you don't have a terabyte worth of data, it's probably overkill because it's what it's designed for. But it will be very, very fast if you put less data in it.
Okay, so you couldn't do the same thing in the default pools then?
Well, so the serverless pool is not a database. So it is a layer on top of flat files. So it's not a database. It looks like a database, it smells like a database, but it's not, because there's lots of database things it doesn't do. You can't do indexing on it. It's not a real database. It just pretends to be one. So it's got some limitations when it comes to performance tuning. You really
Understood.
you can't.
Thank you.
Yeah. Other questions?